All right, you guys, this is the last of the review problems that we have. I think number 4 on the bottom here, if you want to watch, I'll include in when I'm describing the Chipotle portion or the price demand portion of the extra credit that I sent you guys, the Excel mini project extra credit. I sent out one for part 1. So if you want to look at that video, that's enough to help you answer number 4, the idea of where's the rate of change greatest, where's the greatest moment of increase or decrease. Take a look at what I did in that mini project there, the first page only, the price demand stuff, and that should give you a sense of what I'm looking for as far as second derivative in that topic. But if I want to do a related rates problem where I tweak a rate of some kind, like some kind of rate of change of a variable that's in a particular function. So we're looking at profit, cost, and revenue. We can look at how those all change individually, how cost change, how revenue changes, and how profit changes based on increasing the rate of unit production. In this particular, and it's a sports manufacturing supplement company. So one by one I'll go through and just kind of take each function, do the implicit differentiation, which gives us a place to put this rate of change, this new 150 units per week. And you always do it at a certain moment in time. And it's at x equals 1,000 units. So it's still an instantaneous rate of change, so you need a place to find the rate of change as well as the rate to plug in. So here's cost. If you want to do an implicit, there's revenue, and get all the functions. Might as well put those together and get profit. So here's just a quick run through. Don't forget to distribute the negative after this step here to make sure you have the appropriate profit function, combine like terms, and all the good algebra things that you know. The next piece then would be to each individual function, we're going to take the derivative with respect to t. That's the implicit portion. And then we'll put in our rate, our dx dt, and our x as appropriate. So there are, let's see, 1, 2, 3, yep, here's cost. Oops, sorry, chop that off. Derivative of that with respect to t means anytime we hit something other than t, we have to put a dx dt after it. So the derivative of this cost function, 0.75, would be the derivative. But implicitly we have to put the dx dt after. That's where our 150 units per week is going to go. So that gives us this value, 0.75 times 150, or $112 per week of cost increase. So you want to be careful that that's adding costs, which makes sense. You're putting out more product, 150 more units per week. It costs an additional $112.50 per week when the production is currently at 1,000. Actually, in this case, since we don't input x equals 1,000, that's anywhere actually in the function that if you increase 150 units, you'll see per week, you'll see $112.50 increase per week of cost. So the next revenue, want to take the derivative with respect to time. The derivative usually would be with that 250 minus 1/5 x, but now we need to have the dx dt's after each of those. So here they are. And that's the place where we'll put the 150. X remains, and that's the number of units at that moment in time, so you want to put the 1,000 in. And then once you calculate this, this will be our rate of change of revenue with respect to time. And for a total of $30,000 per week increase in revenue. And combine that with that cost that we have, revenue minus cost, and you get your total rate of change of profit. So I'm going to do this two ways. I could take this 30,000 minus the 112.50, so rate of change of revenue minus rate of change of cost, and I could get my rate of change of profit. So it's a quick subtraction, nothing fancy. You get 29,887.50 by subtracting those two. You can subtract rates and get the total rate, so the rate of change of profit, or you could get the profit function, as I've shown here, take its derivative implicitly, put in the x and the 150, and you'll notice you're actually doing the same thing you did before in two chunks. There's a revenue piece on the left, here's your cost piece on the right, the two calculations we already made. We end up adding a negative or subtracting those two, and you get 29,887.50, and that's it. Those are the three components implicitly. By tweaking one of the rates, the number of units produced per week, we can see how it affects profit, revenue, and cost.